Hi everyone and welcome back to Fusion News. I'm Dr. Hazel Lowe. I'm a plasma physicist working on fusion plasma diagnostics at Tokamak Energy in the UK. It's Friday the 9th of September 2022 and this is your Fusion News update. Stories today include 1. Thailand joins hands with China to develop the Association of Southeastern Nations' first artificial sun. 2. Using exascale supercomputers to make clean fusion energy possible. 3. Elemental research. Scientists supply boron to tungsten components in fusion facilities. 4. Contractors alerted to 20 billion fusion energy job. And I also have a couple of bonus items for you at the end. 1. Thailand joins hands with China to develop the Association of Southeastern Nations' first artificial sun. The first story on today's episode is about a collaboration between the Thailand Institute of Nuclear Technology and the Chinese Academy of Sciences Institute of Plasma Physics. As regular viewers of the channel will know, a tokamak is a fusion device consisting of a donut-shaped hollow vacuum chamber surrounded by powerful magnets to keep the extremely hot plasma fuel contained. A tokamak formerly known as HT6M has been brought out of retirement and upgraded over the last couple of years before being shipped to Thailand next month. Thai scientists and engineers have recently been working with their Chinese counterparts on the machine now known as Thailand Tokamak 1 and are ready to run experiments independently thanks to the training they've received. Thailand Tokamak 1 will be the first tokamak to be commissioned in Southeast Asia. An engineer from the Electricity Generating Authority of Thailand explained that, "We have joined with the Thailand Institute of Nuclear Technology to develop Thailand's first tokamak. Besides providing funding, we also support engineers and researchers in this project. Our goal right now is to train our staff to understand the basis of and how to assemble, operate and maintain the machine." While the head of the Fusion and Plasma Division of the Thailand Institute of Nuclear Technology went on to say that, "With this machine, we hope to provide a platform for researchers in Thailand to conduct fusion-related experiments and analyse the data. There aren't many young people engaged in fusion research in Thailand at the moment, but this machine will hopefully inspire more young people to join the field." 2. Using exascale supercomputers to make clean fusion energy possible. The next article is about a big US collaboration project called the Partnership Center for High Fidelity Boundary Plasma Simulation, headquartered at Princeton Plasma Physics Laboratory. They're planning to use a cutting-edge exascale supercomputer to speed up the feedback between simulations of fusion plasmas and real-world experiments to make faster progress towards the goal of delivering clean, sustainable fusion energy to the grid. This research has been motivated by results from Eurofusion's Joint European Torus, which are very relevant to ITER, the International Thermonuclear Reactor which is currently under construction in France. You may be wondering what an exascale supercomputer is. Well, it's a computer system that can perform 10 to the power of 18 floating point operations per second. To put that in context, the Aurora supercomputer housed at the Argonne National Laboratory can perform 2 million times more operations per second than a typical modern home or office computer. And Aurora also has about 1 million times more memory than a typical computer as well. These hugely powerful supercomputers are ideal for running codes that simulate the complex behaviour of fusion plasmas. The collaboration is developing a novel code to try and understand the effect on plasma confinement of having the inner plasma-facing wall made of tungsten, and how injecting lighter elements such as nitrogen or neon can make confinement better. High confinement means the plasma stores more energy, which is needed to reach the right conditions for fusion. Dr. C.S. Chang, who heads up this collaboration, explained that to really understand what's going on and what's going to happen in the next experiment, you need big codes and big computers. Our early science on Aurora is to understand this tungsten wall experiment and how this will be extrapolated to ITER. We need to do first principles-based high-fidelity simulation and fundamentally verify the physics. By using large-scale high-performance computers optimised for artificial intelligence and machine learning, there can be daily communication and progress between exascale computers running large-scale simulations and large-scale experiments. 3. Elemental research. Scientists supply boron to tungsten components in fusion facilities. The third article today is from phys.org and reports on recently published experimental results about this issue of the effect of the tungsten inner wall of the tokamak on plasma confinement. If some tungsten is evaporated and starts to contaminate the plasma, more energy is lost from the plasma by increased emission of electromagnetic radiation such as visible light or X-rays. As I said in relation to the previous story, losing energy from the plasma lowers the temperature and stops fusion reactions from occurring. To prevent this from happening, researchers from the Princeton Plasma Physics Laboratory in the US developed a powder dropper device that can be mounted on top of a tokamak vacuum chamber to drop precise amounts of boron powder into the plasma while the tokamak is operating. The boron is intended to coat the tungsten wall, forming a physical barrier between the tungsten surface and the plasma. As boron is a lighter element, if it starts to evaporate and mix into the plasma, it will emit less radiation, so the rate of energy loss will be lower. The device was tested at the West Tokamak, operated by France's Atomic Energy Commission, and produced really promising results. Adding the boron powder into the tokamak not only appeared to provide a seal between the tungsten wall and the plasma, but also improved plasma confinement without generating instabilities. Grant Bodner, the researcher who developed and tested this device, said, "We need a way to deposit boron coatings without turning off the tokamak's magnetic field, and that's what the powder dropper allows us to do. West is one of the few full tungsten environments that can help us test this technology at long pulses. We saw that when we dropped in the powder, the plasma confinement increased, meaning that it retains more of its heat, which aids the fusion process. Adding any extra impurities, even boron, can reduce how much fusion power you get because the plasma becomes less pure. Therefore, we have to try to use the smallest amount of boron that can still produce the effects we want." 4. Contractors alerted to 20 billion fusion energy job. The final story this week is about the UK Atomic Energy Authority's Spherical Tokamak for Energy Production, known as STEP, which is a huge UK project aiming to build a fusion reactor that can generate more energy than it uses by the 2040s. The prototype reactor will be connected to the UK's power grid as a proof of concept of net energy production, but it will not be a commercial power plant. The UK Atomic Energy Authority have announced that the STEP programme will be calling for tenders from potential partners from the end of this year. Specifically, an engineering partner to develop a detailed design of the fusion prototype energy plant systems, and a construction partner to develop safe, sustainable building designs and manage construction at the STEP site. Each contract will be worth £10 billion. According to UK AEA documents, in mid-2024, STEP is expected to develop from an embryonic programme to a fully formed major programme, bringing together and developing extensive industrial capabilities to deliver a full plant design, a viable supply chain, and to seek the consents needed for construction. And now for the bonus items. There were plenty of articles about fusion energy in the news this week, including articles about recent advances in the fusion energy sector in BBC Science Focus magazine, The Washington Post, and the Financial Times FDIintelligence.com, as well as articles from Newsweek and oilprice.com about the domestic political and economic impact of the USA's fusion strategy. Finally, the India Times published an article about the ITER project and reflects on India's contribution to this multinational collaboration. That's all for this week. Please subscribe for more fusion news and check out the links in the description below if you want further information. And don't forget, you can also listen to fusion news by subscribing to our podcast. Thanks for watching.